Hey, listen up, there's a red alert! NASA supercomputers have calculated that there are only 2,021 years left until the end of the Earth. Our planet is about to… oh, wait a minute. Oops, I'm sorry. I thought these zeros were a mistake. Well, the research actually says 1,000,000,2021 years in the future. Whew, that's a relief. Breathe normally. Still, this means that our planet officially has an expiration date. And no, this is not science fiction. It's a very real study that shows how, why, and when life on Earth will end. So, thanks to NASA and Japan's Toho University, we can now mark the calendar. It'll happen in around 1 billion years. But what about how and why? Well, even as recently as the early 20th century, scientists still didn't know what powered the sun. One of the first big ideas was that the sun was basically a giant piece of charcoal, just a huge ball of fire burning some kind of fuel. But that was easy to rule out. At the rate the sun puts out energy, it would have burned through that kind of fuel in just a few thousand years. And even back then, geologists and paleontologists already agreed that Earth was at least 100 million years old, if not more. That meant the chemical burning couldn't have possibly kept the sun shining for that long. So, scientists turned to another, more nerdy theory – gravitational contraction. This idea was that the sun shines because of its own weight. Its gravity pulls all the gas inward, squeezing itself tighter and tighter. It's kind of like warming your hands by rubbing them together. We know that gas giants like Jupiter and Saturn are slightly contracting under their own weight and giving off more heat than they get from the sun. So yeah, gravitational contraction, also known as the Kelvin-Helmholtz mechanism, is very much real, but it's not what powers the sun. When researchers did the math, it showed the sun could only shine like that for about 20 to 30 million years. Eventually, scientists learned that the real secret behind the sun's power and longevity was something way more powerful – nuclear fusion. Now, deep inside the sun, it's unbelievably hot. We're talking 27 million degrees Fahrenheit. And it's under crazy pressure because the sun is so big and heavy. All that heat and pressure squashes hydrogen atoms and forces them to stick together. When 4 hydrogen atoms get squished hard enough, they turn into something new – a helium atom. When that happens, a little bit of their mass turns into energy, and that's what becomes sunlight and heat. For centuries, people feared the sun would someday go cold, and that will happen, eventually. About 5 billion years from now, our star will run out of hydrogen, and gravity will take over. But long before that, Earth will already be toast. According to a NASA life extinction prediction, our planet will become a scorched, uninhabitable rock, not because the sun will go out, but because it will burn too hot. It turns out that those old apocalyptic ideas were not completely off. The sun will destroy life on Earth, just not by going cold. But why? Well, it's because, with time, the sun is getting brighter. And I'm not talking about its mood. It releases more energy. It's a slow, natural side effect of the nuclear fusion we just mentioned. Deep in the core, the sun has been fusing hydrogen into helium for billions of years. But as more helium piles up, the core gets denser and hotter. Think of it like a pressure cooker. The more pressure builds up inside, the more heat rises from within. That extra heat speeds up fusion, which means more energy gets released, and the sun starts shining just a little bit brighter. It's not dramatic, we won't notice it in a lifetime, but the future-proof androids we're going to build just might. With time, the extra heat adds up. The sun is already about 30% brighter than when the Earth was born. But life decline is going to happen much earlier, even before the given deadline. As the sun keeps cranking up the heat, Earth is gonna sweat. The extra sunlight raises global temperatures to the point where the ocean surfaces hit around 117 degrees Fahrenheit. That's hot enough to mess with the planet's entire climate system. Water vapor begins to rise from the oceans and accumulate in the upper atmosphere. This causes even more heat to be trapped, creating a thick, humid layer around Earth. Scientists refer to this ongoing cycle as the moist greenhouse effect. The rising temperatures aren't just drying out our planet, they're also harming plants. Plants rely on carbon dioxide from the air to grow and thrive. However, as Earth warms up, certain natural processes can take too much carbon dioxide out of the atmosphere. When that happens, there won't be enough CO2 left for plants to survive. Forests will disappear first, then grasslands, bushes, and even the toughest plants that usually handle extreme heat. This all will lead to oxygen collapse, because plants and CO2 are crucial for photosynthesis. In simple terms, this is how plants use sunlight, along with water and carbon dioxide, to create their own energy and produce oxygen as a waste product. Right now, oxygen makes up about 21% of Earth's atmosphere. But once it drops below even 1%, complex life as we know it will most likely disappear. Earth's biosphere will shrink to just a few microbes and extremophiles, hiding deep underground. But even they won't last long. It's worth noting that scientists ran two versions of the simulation, one with life like we have today and one with none at all. Surprisingly, both worlds lost their oxygen at about the same time, around 1 billion years from now. That means plant life and photosynthesis do help, but they're not the main thing keeping oxygen in the atmosphere. It's actually a long-term chemical battle between volcanic gases and rocks that gradually soak up oxygen like a sponge. And even after most life is gone, the heat will keep going, causing oceans to boil. Not all at once, but slowly and steadily, the oceans will begin to evaporate into the atmosphere. But that vapor won't just come back down as rain like it does now. Why? The atmosphere will be too hot and thick for that. Instead, sunlight will start breaking the water apart, and hydrogen will escape into space permanently. Once it's gone for good. Basically, instead of raining back down, Earth's water will slowly leak into space until there's nothing left. Even before the last puddles vanish, life under the sea will be long gone. Once the balance of temperature and oxygen is lost, not even the hardiest ocean life can hold on. In the end, Earth will become something we can barely recognize, a dry, lifeless rock. There will be no water, no oxygen, and no life left. The oceans will be gone. The atmosphere will be thin and toxic. Even the most resilient microbes will have disappeared. However, the sun will still shine in the sky. Earth will keep orbiting just like always. It'll still be a planet, just without life. But long before that cosmic finale, Earth will already be uninhabitable, which raises the big question. So, what could future humans do about all this? Well, escaping sun radiation and extinction might end up being humanity's biggest engineering challenge yet. Maybe we'll build massive space colonies and leap from planet to planet, staying just ahead of the sun's deadly heat. Even if we terraform Mars, making it more Earth-like so we can inhabit it, it'll still be cooking in the same solar oven, just on a lower shelf. Or maybe we'll live in giant rotating space habitats, like O'Neill cylinders, floating mini-worlds with gravity and recycled air, water, and energy to support long-term survival. Those could drift farther and farther from the sun as things heat up. Or who knows? Maybe we'll upload our minds to the cosmic cloud or hop into a higher dimension and watch the universe like it's, Netflix. Okay, this is definitely too nerdy, and we're going deep into sci-fi territory. But whatever the solution may be, humankind has a long time ahead to figure out how to survive the eventual end of Earth and life, or maybe even preserve it in whatever form it takes. Tick-tock. No, not the app, a clock. You see, scientists already know the exact doomsday date. Tick-tock. The countdown has started. We only have 250, no, not years, millions of years left on this beautiful planet we call Earth. Well, let me apologize first. I might have scared you with all these end-of-the-world things. You and I certainly won't live to witness it, but we already know when it will all go downhill, and most importantly, why. This 250 million years deadline is not precise. If we change our ways, humans can stick around for more or less, depending on what way we choose. Researchers ran some computer simulations and found that Earth might be left without any mammals if temperatures kept climbing to between 104 and 158 degrees Fahrenheit. What's the culprit? Well, it's mainly our love for fossil fuels and the greenhouse gases we keep pumping into the atmosphere. It's easy to think that mass extinctions are a thing of the past, especially since the last big one wiped out dinosaurs 66 million years ago. But surprise, we're actually overdue for another one, and this time, it's all on us. Throughout Earth's history, there have been 5 mass extinctions, and it's been 66 million years since the last one. But this upcoming one is special. It's totally human-made. As Earth's tectonic plates shift over millions of years, they eventually come together to form supercontinents. This could lead to some pretty serious natural disasters, and, well, it might as well mean the end. Having one continent instead of 7 is already pretty extreme, as it will totally make us rethink the way we live. Now, scientists said that a new supercontinent would create a trio of problems. The continentality effect – no, I didn't make that word up – a hotter sun, and rising CO2 levels, resulting in a super hot planet. This would lead to tough living conditions for mammals with limited food and water. If temperatures hit 104 to 122 degrees Fahrenheit, and maybe even more extreme fluctuations, humans and lots of other species would struggle to cope since we can't shed heat effectively through sweating. Some experts believe the future looks pretty grim. CO2 levels could end up being double what they are now, and the sun's radiation could increase by about 2.5%. With the supercontinent likely to be in hot, humid tropics, much of the planet could be facing extreme heat. Finally, in about 250 million years, Earth is expected to morph into a donut shape with a big inland sea in the middle, leaving the Pacific Ocean to cover most of the surface. Honestly, no matter how well scientists crunch the numbers, they can't see the future, especially when it's this far out. But hey, those who ignore history are doomed to repeat it. So let's jump into the history of the 5 massive extinctions that have already happened. The late Ordovician mass extinction hit around 445 million years ago and was a huge deal for ocean life, wiping out up to 60% of marine species, including 85% of all marine creatures. Unlike other extinctions, it really didn't change ecosystems much. It had 2 main phases. First, the climate cooled due to glaciation, causing sea levels to drop and many marine animals to lose their homes, leading to new cold water ecosystems. Then, when the ice melted, warming returned, but oxygen levels plummeted, creating toxic ocean spots. I know, it all sounds horrible, but let's see the results. The planet is still habitable, marine life is booming, and, by the way, there are even species, some hard-bodied arthropods like horseshoe crabs, that are still around. So from our perspective, it feels like it wasn't a disaster so much as a step for further development of our planet. But let's not make premature conclusions and take a look at the next mass extinction. The late Devonian extinction was a big deal in Earth's history, happening about 272 million years ago. The main event during this time was called the Kielwasser event, which wiped out about 19% of all family groups and half of all types of living things in the oceans. Another extinction, the Hagenberg event, occurred around 359 million years ago and marked the end of the Devonian period. This extinction wasn't just one event, but might have happened over a long time, possibly from 500,000 to 25 million years. Some scientists think that there were as many as 7 separate extinction events during this period. By the late Devonian, plants and insects were starting to thrive on land, and oceans were filled with huge coral reefs. The continents were also moving together to form what we know as Pangaea. Most of the creatures that disappeared were in the oceans, like brachiopods and trilobites, especially the ones that built reefs. The reasons for this extinction are still a mystery. Some ideas include changes in sea levels, lack of oxygen in the ocean, global cooling, or even volcanic activity. There's also a theory that a comet hit Earth. Interestingly, it seems that the loss of diversity came more from fewer new species forming rather than a spike of species dying out. During this extinction, oceans became low in oxygen, which helped preserve some organic material. This, along with the porous rocks from that time, made Devonian rocks a valuable source of oil, especially in places like Canada and the US, way before they became Canada and the US. So far, these terrible mass extinction events don't sound that bad. Now, about 250 million years ago, there was a huge event called the Permian-Triassic extinction, often called the Great Dying. It was probably the worst extinction event ever on Earth. During this time, a whopping 59% of all biological families and 83% of different kinds of living things disappeared. This included 81% of marine life and 70% of land animals. Even insects were hit hard. Scientists believe the main cause of this mass extinction was massive volcanic eruptions in what we now call the Siberian Traps. These eruptions released a ton of gases, like sulfur dioxide and carbon dioxide, which messed up the oceans and made it hard for many creatures to survive. The atmosphere's carbon dioxide levels skyrocketed from about 400 parts per million to 2,500 parts per million. Other possible reasons for this extinction include burning oil and coal during these eruptions, intense weather patterns like El Niño, and even a possible asteroid strike. All of these factors combined, creating a really tough environment for life on Earth at that time. Okay, this one seems serious. Let's proceed though, shall we? The Triassic-Jurassic extinction event, happening around 200 million years ago, was a major wipeout of many species, both on land and in the ocean. In the oceans, between 23 to 34% of marine life vanished. On land, most reptiles, except for crocodiles, dinosaurs, and pterosaurs, those flying reptiles, went extinct. Some of the reptiles that went extinct were once very common. Luckily, plants, early mammals, and the groups that survived, like dinosaurs and pterosaurs, thrived and became the main animals for the next 135 million years. Scientists think this extinction might have been caused by huge volcanic eruptions, which released lots of carbon dioxide into the air. This led to global warming and made the oceans more acidic. The Cretaceous-Paleogene extinction event happened around
600. Closing the North Sea in a nearly 400-mile-long dam may save Europe from complete disaster. This is not some sci-fi stuff, it's real, and it's called NEED, Northern European Enclosure Dam. It's a last-ditch plan to save over 25 million people from 15 European countries from the rising sea levels. To build this giant bathtub, humans need one dam between England and France, another one between Norway and Scotland, 51 billion tons of sand, and almost 600 billion euros. As crazy as it may sound, this project is totally feasible, except for one teeny tiny detail. The scientists who had this literally life-saving idea don't want the dam to be built. First and foremost, the NEED needs, two dams. One that is 100 miles long and almost 334 feet deep in the English Channel, and another that is 300 miles long and more than 1,000 feet deep in the North Sea. Building something like this requires a crazy amount of materials, like the 51 billion tons of sand we mentioned before, which is basically all the sand everyone on the planet uses in a year. And yes, this dam would obviously be the biggest in history. smashing records like the Netherlands' 19-mile Afsluitdijk and South Korea's 20-mile Semangam seawall. The Need Dam would be 19 times bigger than Semangam. It sounds ridiculous, but it's not impossible. You see, humans are pretty good at building big stuff. Oil rigs, for example, operate at depths of up to 6,500 feet, and the Need Dam would only go down more than 1,000 feet. Plus, China has a 102-mile-long bridge, and the dam would only be 4 times longer. Besides, projects like this dam were done before for the exact same reason. It's our friend Afsluitdijk in the Netherlands, which was built almost 100 years ago. The idea here was to shut off a part of the North Sea called Zuiderzee and protect the Netherlands from all the flooding because most of the country is below sea level. They even drained one of the lakes formed by the dam and created a whole new province, Flevoland. Today, the Netherlands has more than 2,200 miles of flood protection, but it's only designed for a 15-inch sea level rise. Without it, the country would be underwater. So yeah, we could do it, but it's really, really expensive. How expensive? Well, it would cost around 550 billion euros if the project is wrapped up in about 20 years. One wrong step and humans can spend 100 years building this dam, and a couple of billion euros more. The good news is that this much money can be diluted over the 20 to 100 years it takes for the dam to get finished. Besides, the 15 countries it would protect could share the expenses, reducing the amount to only 0.1% of the GDP of all the countries. Not a bad deal to save millions of people, right? Okay, but is this monstrosity really necessary? Well, unfortunately, humans have managed to turn the ocean against us. This means that by 2100, the sea levels are expected to have risen between 1 to 2 feet. If we keep acting like it's none of our business, the rise can reach more than 16 feet by 2300. It may sound like a distant future, but NASA has just discovered that the ocean rose way more than they expected in 2024, which means global disaster is breathing down our necks as we speak. Let's go back to our geography classes for a moment and learn why sea levels are rising altogether. First, because land can sink. The city of Norfolk, Virginia, for example, was built inside a massive crater, and the earth there can erode and sink. Then the soil can get compacted. Because of that, the city is literally sinking into the ground, making it more vulnerable to flooding. In California, some areas are sinking too, but this time it's because of the movement of tectonic plates. Some of the land that is underwater goes up, some of the land over the water goes down. The consequences? Again, heavy flooding. Sea levels also rise if the planet gets too hot. This happens because of a thing called thermal expansion. It has a very scientific name, but it basically means that things like water get bigger if the temperature rises. Half of the reason why sea levels are rising is because of this. This is why the level of the ocean increases almost 10 feet every time the average temperature of the planet rises by 33.8 degrees Fahrenheit. Since 1880, the sea has risen more than 8 inches. Okay, so we build the Need Dam and the problem is solved, right? Well, building this dam comes with massive consequences. First, the ocean currents, think of them as underwater highways that deliver nutrients to tiny creatures like planktons, not the SpongeBob villain, and give rides to animals like lizards and tortoises. A dam this big is capable of messing up the ocean currents that bathe Europe, disrupting the food chain not just inside the dam, but outside too. The currents are also responsible for the climate of coastal areas. The Gulf Stream, for example, is a warm current that comes all the way from Mexico and makes the weather in northwestern Europe a bit more bearable. If the Gulf Stream got interrupted by a gigantic oceanic barrier, it could make parts of Europe even colder. Another problem is that the North Sea would turn into a gigantic freshwater lake. This would happen because the salt water that used to flow from the ocean would now be blocked. And the North Sea would only be fed by the fresh water coming from inside the continent. This process would eventually lead to a thing called desalination, when salt water gets less salty. And it's really terrible because saltwater animals would start to absorb more water than they should, making the cells of their bodies swell. The consequences can be fatal. The disruption of the ocean currents by the dam can also affect the renewal of oxygen in the water. Think of the ocean as a giant recycling system. Surface water needs to sink to deliver oxygen to the deep sea, keeping creatures dwelling at the bottom alive. Without the movement of ocean currents, oxygen would run out and toxic bacteria would take over, creating a poisonous environment for sea creatures. And this is not just a theory. It happened before, 250 million years ago. The ocean got so toxic, it wiped out 95% of marine life and caused a mass extinction. If it's not bad enough, the fishing industry would collapse, and the busiest trading ports of Europe like Rotterdam, Antwerp, and Hamburg would be stuck inside the dam. Sure, we could build sluice gates, but imagine all those traffic jams. The rain patterns of the countries protected by the dam would change too, affecting farming lands and food production. On the other hand, if we do nothing about rising sea levels, permanent flooding could make whole countries disappear. 3 million people on the islands of the Pacific would need to move away by the end of the century. The Maldives would lose 77% of its territories, and cities like Jakarta, Bangladesh, and Lagos would go underwater. Storms would get more dangerous too, destroying treatment plants for sewage and power stations and contaminating farmlands. Rising salt water could also contaminate freshwater supplies, and it's not just happening in Asia and Europe. Philadelphia, for example, is already developing plans to deal with this bleak scenario. This is why the scientists who developed this big red button shaped like a dam don't want people to actually build a dam. They know how bad things can get, which is why they came up with a plan so wild it's basically the engineering version of screaming, "Hey, stop ignoring the planet!" It's a warning. If we don't act now, we'll be stuck building megadams just to keep our cities from becoming Atlantis 2.0. And let's be honest, nobody wants to live in a future where the apocalypse looks like the deep web version of The Little Mermaid.
A super small robot can create its own clones. This robot is so small that if you line up 1,000 copies of it, they would be as large as one single human hair. Wow. It sounds like something from sci-fi, but it's not. These tiny robots are real and could revolutionize medicine, or if things go wrong, turn the planet into a lifeless wasteland. These tiny robots are what we call nanobots, things just a little bit bigger than a single atom of gold. While common-sized robots are usually made from metal and electronic components, these nanobots are made of DNA, the same stuff that makes you, well, you. But instead of using DNA to build a human, scientists have figured out how to fold DNA into tiny shapes, like origami, and create microscopic machines. These machines can do some pretty amazing things, like repair damaged DNA or clean up toxic waste in the ocean. They're like the Swiss Army knives of the microscopic world. But here's the twist. If you put these robots in a place with extra DNA, they can use it to build copies of themselves. That's right, they can self-replicate. And if they get into your bloodstream, they could, theoretically, use your DNA as building blocks to create an army of clones. Pretty cool, but also very terrifying. Now let's say a researcher decides to test these nanobots in a lab. They drop one tiny bot into a bottle filled with DNA and other molecules it can use. The bot gets to work, rearranging the DNA to create a clone. That clone makes another clone, and suddenly, you've got a microscopic factory pumping out nanobots faster than you can say, "uh-oh." It gets worse when you realize that these bots grow exponentially. 1 becomes 2, 2 becomes 4, 4 becomes 8, and after just 10 hours, you'll have 68 billion nanobots in that bottle. Once they've used up all the DNA in the bottle, they'll start looking for more material to feed their cloning frenzy. This is where things start to go south. You see, these nanobots aren't picky eaters. They can break down not just DNA, but pretty much any organic molecule they can find. If this bot can eat anything, it means it can also eat normal carbon atoms, and the moment they all run out of the supplies inside the bottle, they'll start looking for new material outside of it. And, well, carbon is the one element that is common to all living things. This basically means that every animal and plant in the world is made of carbon. Carbon is also the second most abundant element in the human body. You get the memo, right? Carbon is the building block of life, so now every living thing has become food for these nanobots. Those bots are now a huge school of fish attacking a shark, and all they know is making clones. That's basically their whole life. So when the swarm of nanobots eventually escapes the lab, they'll start devouring everything in their path. Forests? Gone. Crops? Gone. Wildlife? Also gone. The nanobots will break down all organic matter into smaller pieces and transform them into new nanobots. Even bacteria and viruses will get eaten, which might sound great until you realize that ecosystems rely on these tiny organisms to function. Without them, the food chain collapses. Bees starve because there are no plants to pollinate. With no bees, the remaining plants can't reproduce, especially if we consider that 85% of plants with flowers need animals like bees to survive. With no plants, herbivores will be the next on the extinction list. When they're gone, carnivores will perish too, because there are no herbivores to hunt. And humans? Well, we're not exactly at the top of the food chain anymore. In less than 2 days, there will be so many nanobots that they will be heavier than Earth. When all the organic matter, this means plants, animals, and obviously us, is gone, these robots will turn to the next best thing – inorganic materials, like soil, rocks, and water. Of course, if we're talking about inorganic things, we must include buildings, roads, and other human-made structures too. In only a few days, Earth's surface will begin to disintegrate. While eating everything in their way, these nanobots will release waste products. Yes, it's robot poop. Except their poo is actually a ridiculous amount of heat that could increase the average temperature of our planet and destroy the ozone layer. If the nanobots are fast enough, humans won't be able to stop them in time. Without food, water, or shelter, civilizations will collapse. If people in some countries manage to survive, they will be living in a wasteland. Now, before you start building a bunker, let's take a deep breath. While the gray goo scenario is a fascinating thought experiment, it's not exactly realistic, at least not yet. First, these nanobots aren't fully independent. They rely on external triggers, like UV light or specific temperature changes, to function. Without human intervention, they'll just sit there like tiny useless paperweights. Second, they're picky eaters, for now. So far, these bots can only use specific parts of DNA to build clones. They can't just chow down on any organic molecule they find, unless someone programs them to. Which brings us to the next point. It's all about intent. The gray goo scenario isn't something that could happen by accident. It would require a deliberate effort to create nanobots that are both self-replicating and capable of consuming everything in their path. And let's be honest, except for Dr. Evil, most scientists aren't in the business of destroying the world. Finally, these nanobots are not invincible. They produce waste in the form of heat and toxic gases. And if too many of them were working at once, the planet would heat up to the point where they'd literally cook themselves. And even if they could survive a ridiculously high temperature, the things they eat, plants, water, us, would not. So no food, no clones. Simple as that. Now that the doomsday scenario is out of the way, let's discuss the cool sciencey part. These tiny guys can help humans cure health conditions without surgery, clean up polluted oceans, or even produce insulin for people who have diabetes. These nanobots could revolutionize medicine, environmental science, and technology. They're like the ultimate multitaskers, if we use them responsibly. The gray goo scenario might sound far-fetched, but history is full of examples where well-intentioned ideas go horribly wrong. Take Australia, for instance. In 1935, the country imported cane toads from Hawaii to eat the beetles that had been destroying sugarcane crops. Fast forward to today, and there are over 200 million toads wreaking havoc on local ecosystems. The beetles? Well, they're still munching away, completely unfazed. So it's a classic case of good idea, bad execution. Technology also makes mistakes, like when we created bacteria that are resistant to antibiotics or malaria mosquitoes that are resistant to DDT. The same principle applies to nanobots. If we're not careful, we might create a problem far worse than the one we're trying to solve. That's why scientists are working on fail-safes, like UV lights or certain temperatures. They also use rare materials, such as diamond or titanium, to build nanobots, so they won't have much material to use if they wanted to start a clone war. Authorities are also keeping a close eye on who's developing this tech and why. After all, the whole gray goo scenario depends on just one ill-intentioned person with a lot of knowledge at hand. Of course, it is a cautionary tale, not a prediction. It reminds us to think carefully about the technology we create and the potential consequences of our actions. Nanobots could save lives, clean up the planet, and push the boundaries of science. Or they could turn the world into a lifeless pile of gray goo. The choice is ours. So, the next time you hear about a breakthrough in nanotechnology, remember, with great power comes great responsibility. And maybe keep an eye on those tiny robots, just in case.
It's one small step for man, giant leap for mankind.
In the late 1950s, everyone was captivated by space exploration. But there was a group of rebels who wondered not what's out there, but what's down there. This team called themselves the American Miscellaneous Society. Yes, that's their real name. And they started one of the biggest projects ever, Project Mahalo. Joyful and determined, they had no idea what a nightmare they started. First, let's understand what the project was about. You probably know that Earth is like a giant onion. If you cut it in half, you'd see it's made of layers. Each one is different from the next. The crust is what we all stand on. It's incredibly thin, like the skin of an apple. It's made of tectonic plates, almost like puzzle pieces, and they float on the layer beneath. That layer is the mantle. It's mostly solid, made of rock, but these rocks flow and move very slowly, just a little bit over thousands of years. They're also incredibly hot, thousands of degrees Fahrenheit, so it's a bunch of scorching stones moving around like caramel syrup. And when the mantle moves, the tectonic plates above move as well. Usually, this movement is slow and harmless. We don't even notice it. But sometimes they can bump into each other, get stuck, and so on. And when they do, they send such horrifying vibrations through the ground that they're hard not to notice. These vibrations are called seismic waves. In 1909, a Croatian scientist, Andrija Mohorovičić, noticed something weird. Turns out, at a certain depth, seismic waves suddenly speed up. He didn't yet realize that he stumbled upon a boundary between the crust and the mantle. It became known as the Moho boundary. Now try to guess what the Project Mahalo guys decided to do. It was during a meeting of the National Science Foundation. Everyone was discussing current scientific progress. Suddenly, Walter Munk, a geophysicist and oceanographer, casually threw out a take that shocked the room. Why not drill all the way down to the mantle? His idea was outrageous. Drill through the ocean floor, deep into the planet's skin, reach the Moho, and see what it's all about. Never mind the fact that the ocean is crazy deep with crushing temperatures and violent currents. Super bold, but not entirely out of nowhere. If we start from the ocean floor, the Moho lies just about 3 to 6 miles below it. It's much easier than starting from land. That would require digging from 10 to 60 miles deep. That made the oceans the best bet for reaching it. Munk wasn't the only one. Harry Hess, one of his colleagues, was just as excited about the time. At the time, people didn't know much about plate tectonics. Hess was one of the founders of that theory, believing that the world is made up of giant moving plates. To him, it was great. Drilling to the mantle would give him evidence to prove that theory. They became a team and found more like-minded scientists. They combined the most brilliant minds in earth science: Roger Revelle, Maurice Ewing, and Arthur Maxwell. They called themselves miscellaneous because there were all sorts of scientists in the team. Poor guys didn't know that their playful name would later come back to haunt them. But the NSF was dumbfounded by their idea at first and rejected it, because duh, it would be a nightmare to pull off. So our team secured $50,000 just to make a plan. Then they presented the official banner. Luckily, science was on the rise, and there were rumors about other countries trying their own deep drilling projects. So the AMS got the green light this time. The plan consisted of 3 phases. Phase 1. Do a drilling test. Check how things are going. Phase 2. Build an intermediate drilling vessel. Phase 3. Keep going until they reach the Moho. And they got a funding of a whopping $2.5 million. And finally, in March and April 1961, the project finally began. Phase 1 took place off the coast of Guadalupe Island, Mexico. They used a converted barge called Cuss-1 and some insane brain moves to make it work. Originally, Cuss-1 was made for drilling oil offshore. It was one of the best things we had for drilling in deep water. But a catch was that it could only go a few hundred feet down. And remember, we need at least 3 miles. The team had to come up with something revolutionary: dynamic positioning. It's a tech that allowed the ship to stay perfectly still in the middle of the ocean, even without an anchor. It worked like this. They dropped 6 buoys into the water, forming a circle around the ship. These buoys sent underwater echoes to help the ship understand where it's located. Using motors and a joystick, the crew could keep Cuss-1 right in the center of the circle. And surprisingly, they started making progress. Even though ocean drilling is incredibly hard, they drilled through thick layers of sediment and reached an astonishing 600 feet below the seafloor, about 2 Statues of Liberty. And the seafloor itself was almost 12,000 feet deep. This was just the beginning. Deep down, they stumbled upon tons of basalt, a type of volcanic rock. It doesn't surprise us now, but for that time, this achievement was groundbreaking. Turns out they got through Miocene-age sediments, rocks formed millions of years ago. This discovery told us so much about the history of our planet. Now the entire world held its breath. Even the famous writer John Steinbeck, the author of East of Eden and The Grapes of Wrath, got caught up in the excitement. He joined the project and wrote a dramatic article about it for Life magazine. He wrote that we knew less about the ocean floor than we knew about the moon. That line stuck. The biggest surprise was that President John F. Kennedy sent a telegram congratulating the team. It's like the space race turned into inner space, and for a brief moment, it looked like they just might do it. But years later, Walter Munk said that the very success of Phase 1 doomed the project. The early triumph raised expectations sky high. From the start, the miscellaneousness of this society led to tons of disagreements, logistical hurdles, and the costs just kept rising. When the NSF realized just how successful the project was, they took over in 1961. The original society became just an advisor, and this completely screwed things up. One of the scientists said that it was a lengthy and unattractive trail of bickering, bitterness, and short-sightedness. They wouldn't even decide what exactly they wanted to do and whether they even want to reach the Moho. After that, the project found the new contractor company, Brown and Root, but it was a political decision, not a scientific one. Brown and Root had no experience in deep-sea drilling at all. Poor scientists had to suffer because this company didn't understand the project's goals and how hard it is. Some scientists even quit because of how annoying that was. As a result, when they calculated how much it would actually take to reach the Moho, it turned out to be about $1 billion by today's standards. This shocked absolutely everyone. The public was mocking them, which didn't help at all. Some articles called it Project No Hole and gave titles like How NSF Got Lost in Mohole. The final blow happened in '66. The project's most loyal supporter, Albert Thomas, passed away. Plus, the situation in Vietnam was escalating. As a result, the project was stopped after eating up tens of millions of dollars. What's even worse, this giant, impossible idea took the funding from smaller and achievable things. But it wasn't entirely for nothing. Project Moholo pioneered a new deep-sea drilling technique, which is now standard. They also inspired many new, similar, smaller ideas. And science just kept going since then. In May 2023, scientists finally achieved this dream. They actually pulled up rocks not even from the Moho boundary, but from the mantle itself. They got them from the bottom of the Atlantic Ocean. So maybe one day we'll be able to drill all the way down there.
So listen up. One day our sun will cool down and turn into a white dwarf. But this is not the worst thing for Earth. Before the star cools down, it will grow to an incredible size and arrange Ragnarok for us. Now, in case you don't know, Ragnarok is the fire apocalypse from Nordic mythology. So our star will burn down absolutely everything on our planet. But hey, don't worry, there's good news. This one day will come in 5 to 7 billion years. The bad news, though, is that almost all complex life on Earth will become extinct much sooner, maybe in 250 million years. But there's a small chance that our planet will be ruled by octopuses. Yeah, I know, this is too much news for the first few seconds. So let me break it all down for you, one thing at a time. We all hear about people destroying nature and polluting our planet. This is all true, but even without our intervention, the vast majority of living creatures on the planet will disappear, including ourselves. The reason is natural disasters and weather change. It sounds terrible, but it's not new to Earth. Scientists have found out that there have already been 5 mass extinctions. The last one happened about 65 million years ago, when dinosaurs disappeared. But life won anyway and took on many different forms. The 6th apocalypse may occur within the next 250 million years. Conditions on Earth at this time will be unsuitable for mammals because the level of carbon dioxide will be twice as high. This will happen because the sun will release 2.5% more radiation and it'll get too hot on Earth. The temperature in most parts of the planet will reach between 104 to 158 degrees Fahrenheit, and the entire land will turn into one supercontinent. In regions with high humidity, the temperature will be even higher, and of course, under such conditions, it will be difficult for people to walk in the park and play frisbee with dogs. No one will play with anyone at all. Let's hope we'll have colonized other planets by this time. Increasing solar fluxes will lead to a sharp loss of oxygen in the atmosphere. This means that in about 1 billion years, our Earth will look like the lifeless place it was about 2.5 billion years ago. That is, before the Great Oxidation Event. At that time, the air was filled with methane, carbon dioxide, and other gases, and the planet was inhabited by the simplest bacteria. Some of them learned how to make oxygen from sunlight and carbon dioxide. Throughout billions of years, they made so much oxygen that it became enough for the birth of new, more complex forms of life. And it seems we will return to these prehistoric times. Now, humans can't exist in such conditions, but some complex life forms hiding in the dark depths of the ocean might be able to adapt to the changed atmosphere and become the masters of Earth. These complex life forms are octopuses. There are many species of these animals. Some live in coastal areas, while others dwell in the deep waters of seas and oceans. And some species may be able to survive and create a new civilization. But why octopuses? Because they're some of the most intelligent creatures on Earth, and probably the most intelligent creatures among all the inhabitants of the dark depths. Octopuses can use surrounding objects as tools. For example, they can wear a coconut shell for protection or shelter. In laboratories, they've used various objects to complete mazes. These animals often escape from their water tanks to visit octopuses in nearby tanks. Yes, they have high intelligence, but not in the human sense. Their intelligence is more like a computer. You see, octopuses have neurons not only inside their brains, but also inside their 8 tentacles and large eyes. It's like a big data center, and their limbs sense the environment in exceptional detail, as if they were the brain. Not only their intelligence, but also their physiological properties might help the octopus survive if the apocalypse strikes. Its body has no skeleton, It can squeeze through any hole, slip past any obstacle, and their 8 highly developed limbs allow them to intelligently interact with their surroundings. Crows can bend pieces of wire with their beaks. They can throw stones into the water to raise the water level and get food. But they only have one beak. An octopus with its tentacles has at least 8 times more possibilities. They don't have spines, so they'll most likely build a civilization not on land but underwater, where it's much more convenient to move with such a body. To build a civilization, they'll need to find cheap energy. For example, hydrothermal underwater springs or tides in coastal areas. This will be a difficult task, but it won't be the most challenging thing for creating cities. It's very difficult for them to maintain social connections. By their nature, they are loners, who usually form groups of several individuals. But this is not enough to carry out large-scale construction of underwater urban areas. Parents pass on culture, history, upbringing, and moral guidelines to their children. They spend a lot of time and effort on education. Octopuses don't do this at all. The female octopus passes away shortly after laying eggs. The male octopus has only one mating relationship in its entire life and passes away shortly after the female is fertilized. So, in a sense, octopus cubs are born orphans. It's not surprising that it's difficult for them to build social connections. Over the past 50 to 100 million years, octopuses have not developed a collective feeling, and it's difficult to imagine that it will suddenly appear in the future. Perhaps something will encourage them. Who knows? Some scientists who study octopuses have noticed that over the past 10 years, some octopus species have shown certain social skills. Some live in groups of 10 or more individuals. If humanity doesn't ruin the lives of these animals by fishing and dumping garbage into the ocean, then they have a good chance of succeeding in conquering the planet. But if they fail, then the next candidates might be nematodes, those little white worms. Well, let's hope octopuses win. They seem cuter. They also may achieve a technological breakthrough much faster than we think, because when you have 8 arms, you work much better. Imagine these octopuses leaving Earth and flying to another galaxy, where they meet us humans. Do you think we could become friends? So let's say octopuses become a highly developed civilization that builds cities in the oceans. But they, just like humans, will have to think about colonizing other planets because of the upcoming Ragnarok. The sun keeps heating up and getting bigger, don't forget. Our star is currently in the most stable phase of its life. It has been in this phase for the last 4.5 billion years. But after another 5 billion years or so, the hydrogen in its core will start running out, and then the fun will begin. As hydrogen fusion slows, the core begins to contract. As the core gets smaller, it heats up until it can kick off another round of nuclear reactions, fusing helium into heavier elements such as carbon, nitrogen, and oxygen. Eventually, the sun will turn red and be so gigantic that it will swallow up Mercury, Venus, and possibly Earth. So, it may be Ragnarok not only for our planet, but for the whole solar system. No matter how tough octopuses are, they won't survive such a disaster. Earth is likely to burn down completely. Maybe it'll look like the moon, or it'll completely disappear. What will happen to the sun next? Its energy will run out sooner or later. Then it will shrink to the size of Earth and turn into a white dwarf. When a star goes out, it ejects a huge amount of gas and dust. Only the cooling core remains. All those outer layers will be floating in space, forming a beautiful nebula, and our solar system will become unrecognizable. Well, in some ways, it can sound pretty sad and scary, but hey, look at the bright side. Yeah, pun intended. It's going to happen in 5 to 7 billion years, so relax. Humanity has been living on Earth for about 40,000 years. If we compress the entire history of our planet into one 24-hour day, then the history of people will be equal to 1 second. If we achieve such a development in 40,000 years, what'll happen in 100,000 years, in 1,000,000 years, in 1 billion years? It's hard to predict. So how about going to the park and enjoying the sun at its best? Yeah, bring some sunscreen.
It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these megaquakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater arms in. They spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin. And if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting.
So astronomers have spotted about a dozen mysterious explosions in space, and no one really knows what they are or why they're happening. At the moment, they occur about 200 million light-years away. But what if, one day, they get much closer to our planet? Now, this all started back in 2018. One day, telescopes saw a giant boom far away in space. That explosion was incredibly bright, about 100 times brighter than a normal star explosion, called a supernova. The strange thing was that normal supernovae take weeks or even months to fade away. But that one went from kaboom to poof, gone, in just a few days. It got extremely hot and huge, about the size of our whole solar system, and then vanished like it never happened. Scientists were seriously confused. Now, they named the explosion the Cow, because its official name was too long and not exciting at all. Since then, astronomers have been hunting for more of those oddball explosions. And indeed, they've found a few more and given them weird animal names too. That's how we got the koala in 2018, the camel in 2020, the Tasmanian devil in 2022, and the finch or the fawn in 2023. All of those are part of a strange group called LFBOTs. That stands for Luminous Fast Blue Optical Transients. Luminous means they're super bright. Fast because they happen and disappear really quickly. The blue color results from their temperature. They're super hot, like 72,000 degrees Fahrenheit. And optical transients means they show up in visible light and don't stick around for long. Even now, the scientists are still scratching their heads, trying to figure out what's causing these bizarre space flashes. It's like the universe is playing a mysterious game, and no one knows the rules yet. At first, scientists thought those space explosions were failed supernovae. That's when a star tries to explode but instead collapses in on itself, kind of like a balloon popping inward. That collapse can create a black hole in the middle that will eat the star from the inside out. But recently, a new theory has popped up, and it's even cooler and creepier. It has to do with black holes, super squished leftovers from exploded stars. They're so powerful that even light can't escape their clutches if it gets too close. That's why they're totally dark and impossible to see directly. Now, some space scientists think that unknown black holes, not too big and not too small, might be pulling in stars that get too close, which produces those explosions. Such holes are called intermediate mass black holes, and no one has actually seen one of those yet. They're like space's biggest mysteries, and we'll try to solve it in a few minutes. But after that, you need to know that a new LEFBOT has shown up in space. It was spotted by a telescope in Liverpool and is currently called AT2024WPP. Yep, scientists still haven't picked an animal name, but they're thinking maybe the wasp. What do you think of this name? Share it in the comments. Anyway, one of the scientists is sure that it's the best one since the cow. The most recent space explosion is super interesting and extremely bright, like me. Maybe the brightest one since this whole LEFBOT thing began in 2018. This new WASP boom also doesn't look like a failed supernova. And still, scientists are checking all the data just to be sure. Now, scientists are pretty sure mid-sized black holes that could cause the explosions must exist somewhere. It's like knowing a secret creature might be hiding in space, but no one has gotten a photo of it yet. Some scientists think that this idea is the most exciting, and that it might even help explain dark matter, one of the biggest mysteries in the entire universe. Well, whatever the truth is, a recent discovery might shed light on the existence of mid-sized black holes. The thing is, when it comes to black holes, space has a few different sizes: small, super huge, and something in the middle. The small ones are called stellar mass black holes. They're around 5 to 50 times heavier than our Sun. The giant ones are called supermassive black holes. Makes sense. They're millions or even billions of times heavier than the Sun. They usually hang out in the middle of galaxies. And then there's the mysterious kind in between, called intermediate mass black holes. Those are like the missing link of black holes. Scientists are pretty sure they should exist, but we barely know anything about them, like where they came from, how they grow, or what they're made of. Good news, that mystery might finally be getting solved. Thanks to several new studies, scientists now have some exciting new clues. Researchers have found waves in space, which are called gravitational waves, that seem to come from black holes smashing into each other. And not just any black holes, but ones that are 100 to 300 times heavier than the Sun, which may mean that they're those mysterious mid-sized black holes. Plus, those are the biggest black hole collisions we've ever recorded on Earth. Now, black holes are like space fossils, super old history clues. And those newly discovered black holes could tell us about the first stars that ever lit up the universe. The problem lies in the fact that our tools on Earth, like LIGO, which stands for Laser Interferometer Gravitational Wave Observatory, only catch a tiny moment of these black holes crashing together, literally just a split second. That makes it tough to figure out where those medium-sized black holes come from. So, scientists have a new plan. One scientific lab is getting ready for a future space mission called LISA, short for Laser Interferometer Space Antenna. It's a cool space project by NASA and the European Space Agency, launching in the late 2030s. LISA will float in space and be able to catch the whole story of black hole crashes, not just the final boom. It will track black holes years before they crash into each other. And, if all goes well, we might finally figure out where these mysterious black holes come from and learn even more about how our universe began. So you might be wondering about how LISA will do it. Remember we talked about ripples dashing through space called gravitational waves? Black holes crashing into each other could send them out. Well, LISA is being built to listen for such waves. It'll float in space and look for all kinds of cosmic shakeups, not just huge ones, but also smaller black holes spinning around giant ones. Now, why do gravitational waves matter? A lot of space stuff is too dark to see with regular telescopes, since no light comes from it at all. But gravitational waves don't care about light. They go through everything, telling us about the secrets hiding in the dark parts of the universe. By studying them, scientists hope to learn about things we've never seen before, like black holes, or what really happened at the very start of the universe, and maybe even things we don't know exist yet. LISA will help us figure out how the universe began, how it's changing, and what it's made of. Now, getting back to those black hole collisions, finding them isn't easy. But researchers have come up with a smart solution. They're using artificial intelligence to make sure the signals from space aren't messed up by noise from Earth or the machines themselves. This work was part of a project focused on combining AI with space science. Scientists are getting more confident that intermediate mass black holes, the ones in between small and supermassive, are real, and they might be some of the most exciting things we can study using gravitational waves, both from Earth and from space. So the next big step? Looking to the Moon. Future detectors placed on the lunar surface could be even better at catching certain types of space waves, especially ones that Earth-based machines might miss. That would help scientists figure out where those black holes dwell in space. Besides this research, scientists are also planning human exploration of the Moon. They're helping NASA choose the best spots for future missions, focusing on big science goals like solar physics, space weather, and how the universe works. Right now is a super exciting time, not just for studying black holes, but also for connecting space exploration and science. So, in the end, will the Sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the Sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. A billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Movile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask, but for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances, and somehow life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow!